previous videos, we have mentioned about the effect of the prestressing force onto the continuous member caused by the redundant supports. This redundant support normally will impose some resistance to the natural deformations of the member induced by the prestressing force, and this will alter a bit in terms of the distributions and magnitudes of the moment and shear in the member. Such characteristic is unique in the continuous member, which is not found in the simply supported member. In this video, we're going to discuss about this response. The slide here presents the moment induced by the prestressing force on statically indeterminate structure, which is the continuous member. First, you need to know what is the meaning of statically indeterminate structure. This is the concept that you have learned from the structural analysis, where if the structure is statically determinate, we can easily determine its reactions by using the principles of static equilibrium. In the more specific term, a structure is considered determinate when the R is equals to 3n. The R here represents the number of reactions, and the n here represents the number of the members. When the R is equals to 3n, you may use the three equations for the static equilibrium in order for you to solve the simply supported member. However, when it comes to the continuous member, it is likely an indeterminate structure. Taking this as an example, there will be 4 reactions, 1, 2, 3, and 4, but there is only one member, which is this. If we perform the determinacy analysis, we know that the R is now greater than 3n. 4 minus 3 times n, there will be an additional 1 degree of indeterminacy. With the existence of this redundant or indeterminacy, you cannot use the equations for the static equilibrium to solve directly. In order to solve the member, you will need to use the force method in order for you to reduce the indeterminacy until the structure is determinate. Then you can solve the member with the equations of static equilibrium. As the force method is not the focus of this course, and by the time you are taking this course, you should have already passed your structural analysis. We will not discuss too much in details on this. Let us come back to the moment caused by the prestressing force within the member. There will be 2 types of moment, which are the primary moment and the secondary moment. The primary moment is mainly caused by the prestressing force, which can be quantified directly by multiplying the prestressing force times its eccentricity. There is an additional moment which is known as the secondary moment, which is mainly due to the hyperstatic reactions, and this is an additional moment required to achieve the deformations that are compatible with the support conditions of the indeterminate structure. To make things simple, you may refer to this diagram. This is a continuous member, one member with 3 supports here, and you are applying a prestressing force at both sides with a predetermined eccentricity along the span. Having this prestressing force times the eccentricity, it will generate a moment acting on the member, which, if without the reaction at the middle, the member should theoretically perform in this manner, same as the response of a simply supported member of the equivalent length. However, due to the existence of this redundant reaction, the deformations of the member is restrained by the reaction here. This will lead to a totally different deformation profile, that you have high deformations at the midspan of each span, instead having the maximum displacement at the support. Therefore, you will need to take into the considerations of the effects of this, which eventually will lead to such deformations, and this is known as the secondary moment. For better understanding on such a response, you may refer to this slide. This is how a continuous beam with an offset prestressing force looks like. In the case that you do not have the redundant support B here, the prestressing force should theoretically lead to the deformation in this manner. However, due to the restraint of the reaction here, the member will deform in this manner. In order for you to find the reaction here, you will need to use the force method for you to find the reaction. The relevant equations are given here. If you wish to know more, you may refer to the structural analysis course. Now, if we look into the response of the member in terms of the moment, let us look at this, which is this element. When you do not have any reactions at the B here, this will be the primary moment along the span, which is due to the P and E. Then, because of the restraint reactions RB here, it will lead to a virtual force in this mechanism that gives you a virtual moment diagram here. Coming back to the principles of the structural analysis, which is the superposition principle, you know that the primary moment and the secondary moment can be superimposed, which eventually will give you total moment diagram as shown here, so that it will yield a response something like this. This explains the effects of the prestressing force onto a continuous member, and this response is only observed from the continuous member. In the case that you have more span, you will have higher degree of indeterminacy. Then you will need to use the principle of force method for you to find all the redundant reactions, and then construct the moment diagram caused by the primary moment and the secondary moment. Next, you will need to superposition both moments in order for you to obtain the total moment diagram.